Okay, so let's start, guys. Some small notes from the feedbacks. There is a link if you want to check them out. So we will not change the schedule. There were not like enough people were just saying that they wouldn't make it if we change. So we'll just keep the time we have. Yeah, as I said, one common complaint was difficulty to follow the missed lectures. So let's see whether from this lecture onward we can have a video of the lecture. I'll try to work a bit on the lecture clarity. It's constant striving. I hope we can get there. The duration sounded reasonable for most people. Someone raised a credits concern, like was feeling that it is a bit long for the number of credits that you would get. I feel that like today, like this year, I think it's too late to change anything in that regard. I don't know how much flexibility you have, like if you have only 3 credit courses. This is 3 credits, right? I am 4. Okay. Is all of your courses this like? Do you in general feel that is too like not enough given the amount of time that you're putting into this? Do you guys care?
Because the amount of credit is based only on the number of hours of lesson.
Yeah.
You don't take in account.
Yeah. Sure. Yeah, no, I can imagine. So I was not considering credits too much. I was just focused on trying to convey the most content possible. But I mean, maybe we can sort something out for, I don't know, if we next year we split the course in 2, like a base and advanced, maybe people who have done it complete this year can get the credits for the advanced part. Like, I don't know. If you guys care about this and some of you actually would potentially need more credits, we can potentially find, you can talk to me in private, we can find a solution. I feel that for this year is too late, but yeah. And another question was where to find reliable information. I have to say that I was mentioning Googling because Googling is actually what I do for like basically all the bugs that I have. I like most of the time when you Google, you automatically end up in either official documentation or issues on Stack Overflow, and that's where I solve the majority of my problem. I can understand that it is not always trivial to like read Stack Overflow messages or read documentation if you're not familiar with the context, you're missing words, etc. But I don't have any other special secret place where to find information. Like usually those are the places. And Stack Overflow is actually very trustworthy, and sometimes you can find answers with buggy codes. But since there are those options to upgrade or downgrade, the first answers that you read on Stack Overflow are usually answers that have been upvoted by other users for which those answers were actually solving the question. And this is the nice mechanism of Stack Overflow, and which in general ensures that the content is quite reasonable. There is another thing. At some point, like in one of the lectures in the 4th module, I wanted to talk a bit more about Git and GitHub, but I wanted to mention like a place where sometimes it is useful, especially when you encounter bugs that do not feel like a problem of your code, but feel like you're using some libraries that are not super standard, and you feel, okay, maybe it's not me, it's that this guy's code is not really well suited to work with my data or whatever. Remember that many of those packages, like I will show it with NumPy. Usually you do this with more remote libraries, but each one of the libraries that you will be using in your life, they always have, usually they are on GitHub. So if you Google NumPy GitHub, for example, those packages have their GitHub page, and GitHub, like as far as we know it now, is just this Google Drive for code, but we'll get to know it better, hopefully. It has this issues section here that you can see. And in issues, there are basically all the people that have been complaining about that library before you, or like have had problems on that library before you, who have like posted stuff there, and the authors of the libraries have posted their replies. So there is a search option. You can try to search for the error message that you're getting, search for the function that you're trying to use and doesn't work. And this is, I think this is the only place where sometimes it's worth looking, that is not necessarily always, like usually you find it also, like this is also indexed on Google, so you can also from Google find issues on GitHub. But sometimes it's worth checking, and sometimes if you're spending you are at the 5th day that you're spending on solving a bug on a library of some guide, and you cannot get your head around it, you can go on GitHub and post a message there. The developers usually get an email notification, and hopefully they're nice enough to help you out. In most of the cases they are. Yeah, so this is in terms of the material. And yeah, more exercises. Some people actually would have been happy to have some additional exercises. First thing that I will say is in the email that I sent some time ago, there were some base material and some intermediate material. I feel that like most of you, I'd say all of you are now at the level to potentially also look in the intermediate material. So if any of you want to look at have some more exercises on NumPy or pandas or objects and classes, maybe you can, if you want, to check out that material, which is also nice because all the links that I sent are also quite tuned to neuroscience and cognitive science data analysis. So if you have time, it can be worth checking. Yeah, so today I wanted to talk a bit about your local Python installation because up till now we have been learning the basics of Python syntax and all the most common libraries that you would use in Python, but we have always been working in this Google Colab, which, I mean, you can use it for like real work, but until now we have more like consider it kind of a playground where we could just write Python code without having to deal in any way with like things installed on our computer, etc. But there are some issues with Colab. Like it's online, you can work on it only when it's online. It is limited in the amount of resources that you have. Like if you leave your code to run for too long, at some point it will just crash unless you get the pro version. You cannot easily access files on your computer from Google Colab. You would have to upload them every time, then download the results. It's difficult to organize. Like if you want to import a function from more than one notebook, it starts becoming a mess doing it in Google Colab. So in general, I would not recommend, like if you're just trying out something quick and you don't want to deal with installing Python on a computer that you haven't installed Python on yet, it's good, but it's not the framework that I would recommend for doing the actual work that you might want to do with Python. So yeah, in the instructions, hopefully all of you have installed following some more or less blindly some instructions. But now I want to actually show you a bit better what you have installed, how all those things are organized, and yeah, in general, have a look at everything that you need on your computer to properly safely run some Python code. And yeah, obviously, these lectures is not paramount to use Python in general. Like you can just keep running code on my Google Colab or on computers where other people have installed Python for you, and that's perfectly fine. But for people who have been trying a bit of Python themselves, they probably have already experienced the fact that one of the most annoying things about Python and recognized widely as his main Python Achilles heel is the fact that sometimes it can be annoying to install libraries. You might install a package, then you need another package. They might have different requirements. Python versions keep changing. Sometimes you have some code that was from 5 years ago and is not working on the last Python version. So in general, versioning of both the Python that you're running and the packages that you might need in your code can be a bit annoying. And so many of the issues that you will find in your, if you start adopting Python for your analysis, will probably be stuff that is related to versions and installing and updating packages. And yeah, it's a very, one of the, number one annoyance that sometimes even prevent people from start coding in Python. And there's even comics about the whole mess, that ungodly mess that this kind of like the Python framework can become if you don't know where to put your hands. So let's avoid get in that situation in like some months of Python usage, and let's try to see what you need, where it should be, so you can make sure that you don't mess up too much your Python installation. So before we start, I wanted to mention like some 101 of terminal usage, because like some people might be familiar with the terminal, some people might have never run anything through the terminal, and can look very intimidating the first times you start using it, but it's actually quite simple. It's like nothing that you have to fear, but to make sure that adoption of the terminal is not too abrupt, I wanted to just spend some words on what it actually is. So yeah, the terminal is, I guess you have all localized it if you have managed to install what you needed to install for today. So for Windows users, usually when I say terminal, I'm referring to the Anaconda prompt, which is just the normal command prompt that you would get in Windows if you search for command prompts. But it has, like before running it, it has some additional configuration that makes sure that you can use it in the context of Conda and Python without issues. On the other side, for both, like for Mac users, this is just the terminal that you can find if you look for the terminal. I don't think we have Unix, Linux users here in the class, so that's why you are. Yeah, okay. But and so I guess yours is just shell or terminal as well. But I mean, I guess you know where the terminal, like what the terminal is. Yeah. So please don't feel discriminated if I just mention Mac and Windows in this lecture. But I guess you can easily translate to that. So the terminal is a nice little machine where we basically have just a text interface to do stuff on your computer. The good thing is it is a bit more deterministic in terms of like instead of like normally when you run programs, you are used to icons that you double click on and they open a program, and then you have a graphical interface to interact with the program. You can load some files, you can save some files, you can do whatever. The terminal is not that different. It's basically doing the same things, but it does not have a graphical interface apart from just lines of code that you can, like lines of text that you can use on the terminal. And basically every time you are writing the name of something on the terminal, you are calling a program which is associated with that name, and you are executing instructions using that program. Sometimes those instructions can take inputs that you also pass in the terminal, in the text lines that you're writing. Sometimes they print stuff on the terminal, which is the output of the terminal, but they are just programs that, like executable programs that are running as the programs that you would normally double click on to run. So for example, if we write on the terminal something like Python after having installed it, the terminal has learned, and it has learned because we have configured this even if you don't know it during the Python installation process. The terminal knows that the word Python is associated with a file that is somewhere on your computer that is an application file, so a .exe for Windows or a .app for Mac. And that executable file is just run the moment we write the name that is associated with that file. Okay. So when I write Python on the terminal has somewhere a table, and one of those places where it looks is this path file that sometimes you have seen mentioned, is one of those daunting things that it's easy to mess up, that you hope you don't have to open and edit, but sometimes you have. And such files are just basically tables that say, okay, the word Python means that I have to open this file. The word Conda means that I have to open this file. And those files are executable, so are programs that will run on your computer the moment you type that word. Okay. If what you're writing does not make sense in the terminal's head, it will get a complaint. Usually something like on my Mac was command not found. I don't remember on Windows, but I guess is something similar. Okay, so that is nothing scary. It just means that for some circumstances, the terminal that you're using does not know where to look for the program that you're trying to run when you get that message. And yeah, so nothing more, like when you use the terminal, you're doing nothing more than just actually calling those programs in a actually easier way, and that is the appeal of the terminal for like when you start becoming used to it, is actually sometimes it's way more convenient to just write something in the terminal than open an interface, click some buttons. Also, for reproducibility, you can do exactly the same that I'm doing in a call to a program if I just give you the string that you have to put on the terminal, compared to a set of instructions like open this, go under the tab, whatever, load, save as. Like, it's actually easier for small, simple programs. Yeah, so after that, we can actually start looking into how does the Python installation that you have put on look like. So we will go through, oh, and yeah, please stop me at any time. I try to pace. Another thing was like, I can assure you that more than one person has told me, I feel like everyone is understanding everything because they do not ask, so I do not ask. And at least 3 people told me that. So for those of you who did, like, you know, like, make sure that like you consider that there are other people in the same situation. So please interrupt me at any time. I don't want to make this faster than necessary. So yeah, parts of a Python installation. I will now show you a bit what are the folders that Python have put on your computer after you have installed it, and like not the whole content because I'm not even aware of the whole content, but just where are the most important parts that you should be aware of when you look with your Python. So yeah, and the structure that I will talk about is the structure that you should have got if you have just now reinstalled Miniconda and Python. It is possible that for some more like ancient versions of Anaconda and Python, you might have slightly different like folder names or stuff in slightly different positions. Hopefully we can track them down. Usually the names look roughly the same, so it should not be too hard to do it. But this is what you should have gotten if you just reinstall it now. So yeah, you will find like for Python to run, Python will need a Python interpreter, which is the executable file, so .exe on a Windows, .app on a Mac, don't know on a Linux, but like this is an executable file, right? So this is just exactly like any other program, something that has been compiled and can interact with the processor of your computer to send our Python instructions and give us back the replies. Apart from this, we find importable modules that are like the standard libraries that Python is shipped with, like all those libraries, sys, random, math, some of the core libraries that you don't have to install yourself if you need to use them. And then there is a place where all the third-party packages, so like NumPy, Pandas, Matplotlib, all those libraries that are not part of the core standard Python package, but we install separately, are put. So let's go through those components one by one. So first of all, the Python interpreter. So yeah, as we said, the Python interpreter is like the most important piece of your Python installation. Usually you find it like if you have your Python directory, usually it's under bin, in the bin folder. Why bin? Because like this is a convention from, I think this started in Unix computers. Like bin stays for binaries, and this is usually the folder where we put all the files that are compiled code. Like executable files are compiled like stuff that that are programs that run that are not is not the source code of the program, is actually the program that you can execute and run on the processor. And yeah, usually such files are in the bin package. In principle, you should find it under, like, in your Python installation /bin/Python and the version number that you have. But we will be looking for these files later in a practical. And it is very important that this location doesn't change, obviously, because we have told the terminal that this is where the Python executable file is. So you go, like, if we move this file, remove it, change it, whatever, the terminal will try to look for this, for what to do when I write Python here. And if the terminal does not find this place, it doesn't know what to do when we try to run something on Python. Then we have the standard library. So again, the standard library is a large collection of modules. So modules are the stuff that we can import, as we were doing in the exercises. And there is a large bunch of them that actually come pre-shipped in Python. And they are all together in one place. Again, if you have installed everything recently, this should be under lib for library. And in a subfolder that is called Python x.x, where x.x is the actual name of your version. And here we will be looking inside this folder later, but you will find a whole bunch of .py files that have a lot of code that is the standard code that is considered part of the core essential to Python, that is automatically put there the moment we install Python. And yeah, the collective name for all those modules is the standard library. Finally, we have what I call third-party packages. Third party in software stands for, like in this case, one party is you, one party is the people who are officially developing Python. Okay. Third party is people who are neither you nor the main core maintainer of the software. And it's like other people who are like the people who coded NumPy, SciPy, Matplotlib, whatever, who have put this package outside for you to use it. And Python provides a way for all those libraries that like people have been developing around to be distributed, and easy ways in which you can add them to your local Python, and we will see how. And yeah, all those packages that we install are put in a folder that is actually inside the folder where you will find the importable modules. There is a site packages folder, and this folder is actually where you will find all the packages that you have installed after having installed Python. Okay, so basic Python comes with a bunch of libraries. Of modules, and like with the standard library, and then on top of that we can install additional things. And to do this kind of installation, we will need to use what is called a package manager. And a package manager is just a little program that allows us to add new third-party packages to our local Python installation. And yeah, we will see later in more details package managers. And yeah, until now, we actually could ignore all of this because we were just running code on Google Colab, and Google Colab already offered us, without the need of an installation, not only the standard library, but also some super common third-party packages that the moment you open a Google Colab notebook are already there without any need to actually install them. Okay, but in real life, if you just install a new clean Python version, you will need to deal with them as well. Yeah, then we have a bunch of optional components. I mean, even third-party packages, you can just work on a brand new fresh Python environment without installing anything. But like that's like almost every time you use Python, you will be using also third-party packages. Optional parts are like, for example, the environment manager, and also this one is strictly optional, but basically every time we run Python today, I'd say that 99% of the people who use Python in the scientific community have been installing it through Conda, like you did. And Conda is a so-called environment manager. And environment manager is a tool to manage environments, where environments are basically compartmentalized Python installations that you can have on your computer that are not interacting with each other in any way, okay? So the idea is I can have many little Python installations, like many separate Python installations on my computer, and an environment manager makes sure that I can very clearly separate them, use one or the other only when I need it, install stuff on one without interfering in any way with what is happening in the other, basically just to keep things separate. And why you often need to keep things separate is, like, as we say, it's very easy for, like, sometimes you have like code that you are developing on your own now and code that a colleague gave you that is was updated 4 years ago and you need it to run. So that code need to run on old libraries while your code need to run on like new libraries. So you have to keep different Python versions, different versions of the packages, etc., etc. So for this purpose, you can very easily do this if you use separate environments, because you can have one environment for your code, one environment to run the code of your colleague, and it doesn't matter at all which kind of outdated Python, outdated packages your colleague code needs, because as long as it is in a separate environment, it does not interfere in any way with what I'm using in my developing environment, okay? Environments are cheap, so usually the recommendation is better one more environment than one less environment. In most cases, you obviously don't want a separate environment for every little piece of your analysis. Like usually one project, consider like, I don't know, in real world, in my case, I have one main environment where I develop basically all the software that I'm using. And if from time to time I have to quickly test code from like a lab that requires heavy, like if it's a very small, simple code, I just run it in my main environment, like in my developing environment. If it's a heavy package that requires a lot of, I don't know, stuff that needs to run on the GPU, compile C code, like libraries that are very heavy for doing very heavy data analysis, sometimes those are convenient to put in a separate environments. Or if I have to replicate analysis from a paper that was using like out several years ago, where I need to use a older Python version than mine, I would also create a separate environment. So yeah, this is, and we will look for where environments are in our installation, but you can imagine that in our case, since we install stuff with Miniconda, like Anaconda, Miniconda is just a minimal version of Anaconda, which is like keeping stuff light, not giving us any user interface, which we don't need, just installing the bare minimum. This is Miniconda, but you can map what we see for Miniconda to what is there for Anaconda quite easily. So we will have our Miniconda folder where we'll find one main base Python interpreter that is called the base interpreter that works like that is the default one. And on top of this, we will actually mount, like there is an environment folder, and inside this environment folder, you will find many little subfolders, and inside each of those subfolders, there is a complete new Python installation, okay? And yeah, the final thing that I will mention is we will actually be running notebooks also on our computers. And so just like running notebooks are not the like the most basic form of running Python code, as you can imagine. Those are like very convenient, but quite, let's say, advanced in terms of the like requirements, kind of infrastructure to write Python code. We will see in a bit more details what are they, how they work. But if you want to install, if you want to run notebooks, you will also make sure to install. It's called Jupyter. The package, like it's a package that allows you to use notebooks. There's also other packages that give you other interfaces to write code. I don't know if any of you have been using Spider. Spider is another package that you would need to install if you want to use it. It can pre-installed if you were installing Anaconda. If you install Miniconda, you would have to install it as another package. But yeah, here we will stick to Jupyter, and we will see a bit more later how it works. Yeah.
What might be the differences between, say, Spider and using Notebook as a functionality?
I'd say so. Let's talk about this when after we see notebooks. Okay. Remind me to go back to this question when we get there. Oh yeah, sorry. There's actually one last thing that I wanted to mention is apart from the packages that you have installed, like the base ones that come in the standard library, the third-party ones that you have installed, you can also add some libraries, like some packages that you write. Like imagine that you write a collection of utility functions that you want to use in many different projects where you need the same pieces of code. You can, and we will see how to do it, you can organize your code in a way that is importable. So you can define a function in one place and import that function from, for example, many different notebooks where you're running an analysis, so you don't have to copy paste code. And this is another piece, this will become another piece basically of your Python installation. But we'll see this later. And yeah, as I was mentioning, all those tools that we will be using for managing this environment are all terminal tools. Anaconda, if you were installing the whole messy big Anaconda, give you also, it's called the Anaconda Navigator. My super strong encouragement is do not use the Anaconda Navigator. Is way more easy to understand. Like at the beginning, it can look less intimidating and more like user-friendly, but it is actually harder to do in a reproducible way the same things. And if you're, for example, asking for help, it's much better if the person who is helping you is given just what you are writing on the terminal compared to I'm clicking this and then I'm selecting this and then. So my recommendation is do not use the Anaconda Navigator if you have it. And I was actually recommending doing the installation using Miniconda, who does not even have the Anaconda Navigator. So yeah, if we write in the terminal, for example, Python, as we say, this will run the Python executable, and this will actually we can do it. Like this is my terminal, and if I just write Python, this will open me a little interactive Python session where I can say a equal to 0, a plus 1, and this will give me the answer. And like basically I can run like a little interface in the terminal where I can run Python code line by line. Not very convenient. You almost never write code one line by one line. Maybe just if you want to test stuff. But yeah, this means that when I call this function Python, this opens this program. I have a whole bunch of other things like, I wanted to mention this because it can be convenient later. If you want this will work with Python. It won't work for any other program. But if you want to be sure of what is run when you write Python, okay, from inside the Python session, you can say import sys, and sys is a library that gives you a whole bunch of utilities that can be useful to understand the kind of system of the Python installation, like where your Python installation is in your operative system and this kind of very core basal things. It has, like, we can look for sys.executable, and this will tell us the path of the executable file that has been run when we wrote Python and is running now. Okay, so this string is actually where in my computer this executable file is. And sometimes this is useful because, like, maybe you write Python and you think you are using one Python that you have, but you're actually using another Python, like an environment that you have activated, or you forgot to activate one environment, and sometimes it is useful. Yes?
And indeed, my Python is not inside the binary folder that we inside the environment that I created. Did I make something stupid?
No. That is good. Like that is perfectly fine. But probably this means that you are running Python after having activated the environment.
Okay.
So
Yeah, I activated the
okay,
environment.
then it's perfectly fine. Yeah,
Okay.
you're just one step ahead. we will get there. Yeah, but also when we write any other commands, like when we write conda, so we can exit, writing exit. When we write conda, this is again another program, like just conda itself does not do anything. This prints actually tells me that, okay, if you want to do something useful with conda, you have to write conda clean, conda compare, conda install, conda whatever, okay? Because conda itself is recognized as something, but is something that like is a program that to actually be called, like run, needs more specification that I'm not giving. If instead I was running just people or something that has no sense for my terminal, I just get a complaint about the fact that yeah, it is not finding this command. Okay. Yeah. So we will be experimenting with the terminal. It's important that the terminal becomes something that you are not scared by, because to use many of those things, it is very useful to interact with this guy here. Yeah. So in your case, as you mentioned, you will find two environments, like two Pythons, executable files in your miniconda folder, where one Python will be the main base Python, which is what I was just finding here, which was in miniconda being Python. And you will find another one inside the environment called course environment, as you which you created, and this will be inside the environment folder, inside the course environment folder. You will find inside bin. You will find this this executable. And yeah, the base Python, which yeah we just mentioned where it is yeah, and as we said, the bin folder stands for binaries. So you will, in the same folder, if you go there, you will find a bunch of other files that are .exe, .app, that are other things that like you will find, for example, conda there, like other things that other little programs that you can run from the terminal, and they are all in bin for binaries. So the important thing that I want to mention here is this is not strictly mandatory. You can forget about this thing if you don't want to bother thinking about this. But my recommendation, if you want to keep everything clean and tidy, is do not run your own code from the base Python, because the base Python is not only running your code, but is also like many of the tools that keep those environments are written in Python and are run through your main base Python. So most of the times nothing happens, but it can, at some point, you can have issues and conflicts between something that you just installed in the base and libraries that you add there. And if those conflicts are like, usually you can solve them, but if you can't and they mess up things, instead of just messing up things inside an environment, which is completely compartmentalized from all the rest, they will mess up things with your base Python. And like usually the output, like the result from that is you just terminate your Anaconda installation and you start from scratch with a new installation. So my recommendation is always made them, like even if for your basic code, like this is why we have one folder that we have one environment that we made for the course. Please try to always keep the code that you will write for the course, always run it from this environment. And if you will be writing Python code on your own, just keep working in this environment or make another environment, but always work in a, like, if you decided to go through Miniconda, which I would recommend, is not mandatory. You can also have a Python without Anaconda. It's just very convenient. Just always work inside an environment. Okay. And yeah, the second Python that we have, as we mentioned, is the Python that is in the environment. So this one will be under AMS, CourseEnv, and again in the CourseEnv folder we will find the whole structure of a Python folder. So we will have another bin folder with another Python executable inside. Yeah, and if we actually want to switch, like in the terminal, the moment we open a new terminal, like in my case it's terminal, in your case it will be Anaconda prompt, many times you will actually see base written between brackets, and that is actually reminding you that whatever command you write here will be going through the programs that you have in your base folder, like in your base bin folder. So if I am with base active and I write Python, I will be running the Python executable file that is in my base folder. If I want to instead, let's say, get inside one environment and start running the executable files that are inside that environment, okay, then I first have to conda activate that environment. So name of the environment, CourseEnv. On my computer is underscore. I probably said to use, well, doesn't matter. It's just a name. So after you conda activate one environment, you have seen that the content in the brackets has changed to the name of the environment that you just activated. And this means that now if you run Python, we are using another Python, which is the Python of the environment. So if we do the same that we did before, import sys.executable. Now the executable that we are running is under AMS CourseEnv bin Python. Okay, so this is the way in which I can be sure of what I'm running. Lots and lot of headaches will arise for sure at the beginning from, like, you think you are in the base environment while you are in an active environment. You think you are in one of the environments, but you actually are in the base. You have to think about what you're doing, where you need to be for what you're doing, and make sure that you're running whatever instructions that you're running from the right place. So from base or from the environment, depending on what you're doing. Yeah, so the first practical is actually, maybe several of you already were following along, and that's very good, but like let's make sure that everyone can locate the executable, like the base Python executable and the executable in the environment. And you try to run it from the terminal writing Python, and you try to check the location of your executable from sys, like for both the base and the course environment.
Fai benissimo, perché secondo me vedere questa idea, se c'è qualcosa di quello rimane io può essere precario, quindi allora dopo che vi ho fatto l'installazione, ok, se avete già fatto l'installazione,
da qui a scrivere quello che avevo scritto in sys sys.executable. La mia scommessa è che sarà lo stesso del tuo base environment executable. Prova a fare. Yes. Sostanzialmente tu forse hai scritto nel pezzo ora hai scritto e sostanzialmente hai dato un altro nome, cioè hai detto a Jupyter installami questo questo Python executable di questo environment con questo nome, ma in realtà gli hai detto di riferenziare hai l'altro nome ha sempre lo stesso lo vedi con il notebook, se tu adesso non lo facciamo ma sempre il notebook del tuo base, cioè non specifichiamo l'environment, vedrai che l'executable è sempre lo stesso, perché hai fatto il comando per registrare un nuovo environment ma da base environment
e c'è una versione sola.
No, scusami, non questo dice crea una content environment con un nome in questa roba qua e con questa versione di Python. Allora quindi ci vorrà un attimo, prova a sentire le istruzioni.
No, posso chiederti sto facendo installazione perché non ho nomi. Praticamente alla fine di tutto ho fatto il livello, ho fatto la test, il notebook.
Perché sei dentro le environment, devi prima uscire o chiudere determinate actività. Ok? Perché questa è un'altra cosa, ci arriviamo. L'idea è che Jupyter, siccome Jupyter è, diciamo, fa parte del tuo setup Python, però non lo puoi specificare, cioè siccome è una roba velocemente andrai con environment diversi. Tu idealmente vuoi avere un Jupyter solo, perché se cominci a installare un Jupyter per ogni environment che hai, poi da dentro l'environment non sai, cioè se apri Jupyter da dentro l'environment non sai in che environment sei. E se ne vuoi lavorare su due environments, su un progetto di un environment, su un progetto di un altro, devi avere due Jupyter, cioè diventa un casino se hai Jupyter dentro il tuo environment. Quindi il modo in cui ve lo fate installare è un unico Jupyter nel base, ok? E da lì puoi specificare notebooks che si agganciano a eseguibilità diversi tra un notebook e l'altro. Però il Jupyter Notebook è soltanto che girano ognuno nel suo environment, però l'interfaccia, cioè l'interfaccia diciamo, grafica di Jupyter sarà sempre nel base. E poi quando sei un nuovo notebook lo puoi creare facendo in modo che utilizzi come kernel un software, ma non
alla
puoi
forza, è stato dato un pacchetto
non puoi
generico.
shutare down la tua sessione, quindi devi darmi un
Sì, in teoria
Non capisco. Bonus.
Poi così lo metti a schermo pieno, no? Sembra che sia uno
Infatti,
smartphone
vai.
solo per fare scena.
Fai molto da riuscire a metterti un altro vantaggio da non solo ecco, un altro.
Avevo dei
La schermata.
grossi aggiornamenti di conda da fare.
Tipo 2017.
Guarda, la versione se la versione 3 punto qualcosa è uscita la versione 24 punto qualcosa, come aggiornare? Ok. Siete installato giusto al Python per
Voi tutto fatto? Tutto perché doveva essere spuntato?
Adesso lo facciamo.
Mi è venuto sincero quello che diceva Matteo, che non so dove si è installato il strumento del notebook, perché avevo già installato UNITn mesi fa per un altro corso, e come faccio a essere sicuro?
Allora, se apri se ranni Jupyter Notebook e apri un notebook base, a quel punto puoi usare lo stesso trucco per dare
Import sys, per avere un check.
Dove ad esempio io posso pensare al Python in realtà.
Fantastico. Exit una volta che avete aperto once you have opened Python from the terminal you can quit just writing exit and brackets.
Ah, ma questo è doppio, ma che per il
Suona con l'ambiente.
Too late.
Okay, so I would probably go further if people are struggling or like still had to figure out some installation thing, we can keep going in the next practical round or at the end of the lecture. So yeah, as many of you did, well, we were doing it also together, so I can do it again. So ideally from your base, you can write Python, and as we say, we enter in this session, and we can say import sys, and then sys.executable. Oh, note that here we are put like, you should like, this is not how you normally write code. Like here we are putting more than one line in the same line separated with like semicolon. This is not how you normally write your scripts, but can be useful not to run things twice here. And this is our reasonable place for the executable to be found for the base environment. So under Miniconda, bin Python. While here we have the environment. We already entered before. So this terminal here is in the course and environment. And we can say Python import sys.executable. And this is actually under miniconda, ems, cursenv, bin, Python. This Python session will remain open until you write exit and this close it. I think that also Control C, maybe, no, exit. You have to exit in this way. Okay. If you want to go back to the base environment, you have to conda deactivate, and this will go back to the base.
So what do you have to do to come back to the base environment?
Write conda deactivate.
Deactivate.
So with environments, the terminology is you activate environments, you deactivate environments. You have an active environment which means the environment you are working from now.
So exit would be just for Python.
Exit is a Python command that I quit the Python session that is open.
Okay. But you still be in the environment that you are in.
Yes, exactly. So you will see that when you write Python, so each of you might have a terminal that is configured differently. So you will see a whole bunch of things here that can be different from what I'm seeing in my terminal. This depends on what you have. But all of you, the moment you write Python here, you will all get those three things. Because basically now, after we wrote Python, the command Python opened a program. And we are running, we are inside this program now. We are not on the terminal, okay? So those three little arrows are reminding us that the instructions that we write here are not terminal instructions, are Python code now.
In principle, you could be programming from terminal.
Potentially, you can be programming all of your code here. I would not recommend it, but in principle, you can. Okay, but now this is not terminal. This is a Python, let's say, text interface. You have a very minimal interface where you can just run things. You cannot click and save files or write scripts or whatever. You can just write instructions and run them. But it's important to know, so if I now write Python here, this will complain because there is no variable called Python. Because this is as long as I am with the three arrows here, this is not terminal anymore. This is a text interface for Python. Until I write exit, and this shut down the Python program and puts me back where I was. Okay. The same way people have noticed, if you write Jupyter Notebook, this will open a terminal, print a whole bunch of stuff here, and this will not allow you to use this terminal anymore until you shut everything down with Control C. And this is because until you have shut it down, this is not a terminal anymore. This is an interface with the Jupyter Notebook session that you have open. Okay, so after we have seen this base structure, let's see what is actually the most minimal way in which you can run Python code. Because we have been using the notebooks, which can be useful and nice, but they are definitely not the most minimal way you can put together assembly Python code. So let's actually do it the minimalistic way. So a Python script is actually nothing more than a whole bunch of Python code lines that are meaningful for Python, that are put together in a text file. Okay, so we can actually just we can literally directly use the text editor of your system, like Notepad or TextEdit in my case, and we can actually literally just create a new document where we write some Python code. I don't know, for let's keep it simple. A equal to 0, and this is not convenient. I have all the autocorrection thing. Oh, this is probably small. Can you guys see it? No?
No.
So let's... And the terminal as well probably was a bit small. Okay. Please interrupt me, guys, when I'm... Okay. And we can zoom in the terminal as well, I guess. Bigger. Bigger. Okay. Sorry. Is this fine now? Okay, good, great. Please interrupt me, guys. I would love to be interrupted more. Okay, so we can just say print and our usual syntax. A is an A, so this will actually print the value of A, correct? So we can save this as test script, and to keep my point to come across, I will actually just keep the extension .txt, okay? So I'm saving it in the desktop. So now in the desktop of our system, we have a little txt file that looks like this, okay? And to execute this txt file, the command, like we can run this as Python code if we just write in the terminal Python followed by the location of the script that we want to execute. So in this case, this will be users, my username, desktop, script.txt. Okay. So if I just run this, in this case, since Python is followed by this argument, like this is basically an input to the program. In this case, this will not open the little terminal. This will actually run the script using that Python interpreter. And my script was just printing something, which is what I get here as a reply in the terminal. Okay. So this is essentially what a Python script is, just a txt file with Python code. And yeah, if you please try to.
No, just like it saves me this file in a RTF format.
You have to make sure that you save it as a txt file. Yes, like it has to be.
It doesn't give me the chance.
So are you on a Mac?
Yes.
So on a Mac, you should have. Sorry, let's open the txt file. You should have format here. And you can say found it.
Yeah.
Okay. So for the other people who are on a Mac, if you need to change this, you have to go. So if you like, in my case, my Notepad editor, like my text edit, is saving txt files with like normal plain UTF encoding. But like sometimes by default, it can save more structured files, like are called RTF files that also have some formatting, while we just want the text. We do not want in our file any more information than the text. So you want to change the format to be like instead of rich text. So you will see something like this, and you can change it to make plain text, which just keeps the text. I think that Windows users do not have this issue. Che forse non è l'ultimissimo, se sei sicura che sia l'ultimissimo, forse il problema è che sei su una Cognitive su Uniconda, non lo so.
Ah, ok.
Forse è l'ultimo. Ma non fa niente, no, non fa niente, basta che.
Anche perché conta che
No,
cioè,
va bene.
quando l'avevo installato Antonio perché io
No, ma per vederlo, basta che tu ne veda due, basta che tu sappia dove è uno, dove è l'altro, quello del tuo end e quello del quello base. Sì, non c'è nessun problema.
Ma vedi che già guardo
Guerra sul
Ok.
ma io ho questo
No, allora prova a mettere le. Però bisogna anche aspetta, maledetti Windows. Prova a mettere all'inizio, mentre la tua corso, prova a dargli guys, I always forget how much of a hassle it is for Windows users to specify path to the terminal. No, the person is very Girando di tutti? Ok, ok.
Ma io devo girare.
No, vabbè. Se dai la spiegazione meglio, sono più contento se
Non so se poi
vabbè. Sì, non è specificato questo step, che tu adesso sei dentro file. Quindi per attivare la distribuzione invece devi tornare. Quindi prima devi fare exit.
Lo dice il terminale.
O aprire una terminale, sì.
Lo dice il terminale.
O continuare.
course and
Poi però puoi viverci
no,
le hai per un motivo? Ok, allora abbiamo deciso sarebbe con calma se non le usi servono io le razziere soltanto per la
mi servirà se lo fai ma lo potrò reinstallare grazie io
Devi fargli vedere cosa dice il terminale. Poi faccio una foto e glielo faccio vedere. Anche se non c'è. Se tu lo dici
metti una vedete tra virgolette
scritto così è il computer.
questo è il motivo per cui quando cominci
Scusate.
no, sì, adesso ti sta dando una grave dentro no? Perché non hai usato la parentesi, non hai usato dica?
No,
Io a volte faccio viceversa, quando fai il veloce, lo apro invece che attraverso infatti dico se sono sicuro per cambiare, se perdi i colorini è impossibile programmare, cioè che inizi delle conoscenze di programmazione che può avere il informi di scrivere.
Dal terminale tu puoi, adesso sei messo in una cartella che di base è la tua cartella del tuo user, quindi tu puoi dire tipo cd e poi il nome della cartella dove vuoi entrare, quindi cd sta per current directory, prendi la current directory,
sto facendo
Siamo a zero.
puoi fare il precedente per chiamare ci guarda, non ti so dare una risposta Okay, so I think that most of you guys are actually good. So, I mean, we were doing this together, so we just continue with the lecture. Probably you have appreciated how much of a hassle can be to work with the file path in Windows. One of the things that people complain about Windows is that. You also probably, some of you appreciated how you never use folders with spaces when you code, because if you do, you have to put everything in quote for the path to work. Otherwise, the problem is in the terminal, everything that is separated with a space get parsed as two different things. So if you have a file path that at some point has a hiatus because of the space, this is parsed as one non-existent path, which is everything until to the point where you have the space. So just start now with the attitude of with the habit of never use spaces in your file system. Whisper you semantics. Okay, so yeah, obviously now we were just calling our file txt, but a useful and reasonable convention is we will always be writing .py file, calling our files .py when we put Python code inside there. And yeah, apart from that, we also do not use Notepad or TextEdit to edit our code, obviously. I can make some recommendations for people who want to yeah, we will get to this. Usually, if you use notebooks, you actually don't need other text editors. There is a text editor that we will see in Jupyter. There are more powerful text editors if people need to start writing very long scripts. One is Spider, but there are actually also there's others. Yeah. So next, packages. So as we say, Python packages put together a bunch of functions and classes that we can import from any notebook or scripts that we are writing, and we have already been doing that when we were importing whatever in our notebooks. So let's now understand what those packages are. So you, for example, can find all the modules that are part of your standard library, so the ones that you don't have to specifically install, also in a folder inside your Miniconda installation. So if you go to this path, so it's under, for example, here we are working with environment. So in the lib folder of the environment, you can find a Python 3.9 folder, or people who have a different Python version, whatever other Python version that you have here. And if we actually go here, we will see that we can find course env in the lib folder in Python 3.9. We will find a whole bunch of .py files. Okay, so those are all .py files that have been put there when we install Python, and some of those, many of them, will have very strange names, but some of those we actually recognize. We can find, for example, random.py, which is something that we were importing stuff from. We can find sys.py. Where is it? Actually, it's called, it has a different name. So let's stick to random.py, that is easier. So random.py is actually, we can open it. This is just a Python script written by very good people that are taking care of the Python core library. So sometimes it's actually, when you have the chance, sometimes it's actually interesting to have a look at what those people are, because you can make sure that the standard library is written by the best Python programmers that are around. And you can find that inside this random.py file, there are a whole bunch of classes and functions that are actually very similar to what you were coding in the lecture. And this is where all those stuff that you import are actually implemented. So sometimes it can be useful for whatever reason to have a look at what exactly something that you're using is doing line by line. Sometimes this can help, maybe not with those super core libraries, but the same principle apply to anything that you have installed. And the very good, nice thing of having all those open libraries that are accessible to us is that we can go and look into any line of the Python code that is powering the standard library. Okay. So yeah, actually in the next practical, what I want you to do is to actually go and find this random pi file, try to modify it by just adding some neutral, very innocuous line, something like a print. And then you will see that next time that you import this library, you will see that hopefully if you did everything correctly, you will get the file that you, like the print that you have added to the standard library, just for you to be convinced of the fact that there's nothing more than just Python running all that code and giving you the classes and functions that are defined there. So yeah, start by locating this folder in your computer, then find this file. This file, as we saw, is just a txt file under a new name, which is .py. So you can open it with whatever txt editor that you want. And yeah, you can make a copy if you do not feel comfortable editing it. So you can make a backup copy somewhere else on your computer, and then just edit and try to import random after you have edited the file.
Sì, perché prima sì, però per lei sì.
Did all of you guys sign the attendance sheets? Allora il problema è che tu adesso qua vedi scritto Python, quindi adesso qui non sei più nel terminale, sei dentro Python, quindi prima di fare exit e poi di mettere tutto nella stessa linea Python e
Di solito, sì, scusa, no. Dovevo vedere per l'autorizzazione all'accesso completo del disco alterno, che non ce l'aveva. Ma anche siccome mentre facevo quello mi sono perso l'inizio del tuo discorso, aspetta, qui lo non credo che
non da qui, allora da file system, cioè devi aprire l'Explorer,
ok, dai, fammi vedere.
puoi metterti a programmare nella tua cartella delle norme.
Ok, ok.
Sì, se anche il tempo fa.
Allora sarà proprio.
Sì, uno dei problemi con queste qua è che periodicamente realizza la mano, forse non era una buona idea organizzare tutti quelle cose che
Cambiano
così periodicamente.
Sì,
casina tutto.
sì.
Yes. Sì. Ma vai dal fare storia. Sì, non terminiamo. Proprio, sì, da un libro lo troverai tu avrai la cartella con user slash over quindi a quanto pare hai questo Python qua e a quanto pare non è Python qui quindi facciamo finta di non averlo visto vai nella cartella del tuo user la cartella di base del tuo user di solito se tipo vai su C no, utenti il tuo utente questo è la qui dovreste avere una cartella anche con ok
questo punto.
qui dentro dovreste avere una cartella Linux login environment qui dentro dovreste avere il course end e qui dentro dovreste avere libro prova a scrollare giù vediamo se ci sono sì qua
Io adesso proprio first domain qua prima di
sì
ok.
sì
E quindi io posso modificare direttamente questo
intanto che non introduci tipo errori di sintassi se tipo apri una parentesi non la chiudi allora lui ti dice cioè
ma poi dovrò cambiare di nuovo quando tornare a cambiare.
sì, esatto, per quello che dico, metti sopra una linea così poi puoi cancellare la linea e sei sicuro che fosse la è unificato questo è il file prima. Ah, ok, no, però quello che devi importare è il file originale, non la copia. Cioè tu devi modificare proprio il file originale che si chiama non basta fare una copia per piccola copia devi proprio modificare il file. Cioè la copia era per dire se non vi sentite sicuri di modificare il file, allora se volete fare una copia, però devi modificare il file che è random.py e poi importare. Sì, in teoria sì. Allora, vediamo un po', hai cambiato random, hai aperto random e l'hai cambiato per essere
Se lo faccio vedere no.
no, chiudo, cioè esci cioè almeno esci da Python e rientri a Python forse non serve chiudere il terminale e riaprire il terminale impostato devi modificare quello dell'environment non quello di base perché nei due di random hai il random del base e il random
Quindi se noi prendiamo il Python base
scoprire l'interfaccia della run e dire come risolverlo.
Però forse
Ci sono, aspetta, devo essere visto, magari aprire il run.py, cioè da tipo un testo di allora, in uno script di Python tu puoi specificare del codice che viene eseguito soltanto se runni lo script come scritto. Tipo in questo caso la maggior parte del codice run quando tu fai import random, tutto quel codice di run. Tutto tranne l'ultimissima riga, che ha questa condizione, il name equal to name. Questa riga qua viene eseguita soltanto quando tu runni lo script come scritto, quindi Python non vedo lo script. Quindi soltanto quando runni lo script come script, lui fa i test e prende quella roba lì. Comincia a dire, è una torna di sé, tu non lo sai, c'è sempre una variabile che puoi controllare, che si chiama underscore, che dovrebbe essere, non ricordo un po' il nome del file che stai eseguendo, da cui stai venendo eseguito il codice. Non so. Lì cominci a tratti in Python abbastanza in su. Però è il motivo per cui fai test e non li fa quando fai tutto. Grazie.
no, solo per assicurarmi di non aver fatto il cappello troppo grosso. Io ho fatto solo che ho saltato il passaggio chiave di farlo nell'environment. Però poi in teoria, cioè, ho visto la lavorate, ho provato a vedere
queste cose qui siete ottimi nella visione delle cose.
non prende fuoco.
Tanto lo fai.
Comunque ho visto che hai il libro adesso così visto
L'ho scaricato. Ho letto l'intro. L'ho fatto. No, ma vedi che non solo ti sta succedendo quello, ti sta anche usando quello che stavo spiegando prima. Vedi che ti sta portando anche su questa roba massima. Allora, non dovrebbe, nel senso che io quello che ti dicevo di fare, tu adesso stai runnando lo script run.py. Io quello che dicevo di fare visto che comunque di importare la libreria, perché importare la libreria o runnare lo script non è la stessa cosa. Cioè ci sono, è quello che stavo spiegando a lui, c'è un pezzettino di codice in quel modo random, che viene eseguito soltanto quando lo runno e non viene eseguito quando lo fai import random. Per quello quando fai import random normalmente si viene inventato import random.
Non so se
No, vedi, perché esatto, perché prima devi accendere Python. Perché se scrivi Python e scrivi altre cose è come se stessi passando degli argomenti a Python che lui interpreta come script. Cioè non c'è nessun guarda, parla con lui l'ha risolto un attimo. Sei sicuro di aver modificato quello dell'environment?
quindi vai, prova ad andare su
Molto bene. E sei sicuro che quello che hai aperto qui nell'editor sia quello che sei? No, vedi, questo quello che mi stai mostrando non è quello che sei environment, ma vedi che non è nella cartella dell'environment, ma è nella cartella del mio. Quindi questo qua è quello del tuo base. Vedrai se vuoi adesso, vedrai che se esci da Python, non sta modificando, se esci da Python, riattiva l'environment e controlla che lo segui quando fai
quello fa il test.
Quindi solo tipo random.py. No.
Python e poi no, Python e poi devi dargli tutto il file path fino al
E domanda, perché qua c'è il tag scrivi qua sopra?
in che senso per l'accetta?
Le altre volte che mi è capitato di lavorare con il file Python, dove c'era tipo una parte commentata, a scrivere cose in prima riga, l'errore quando scrivi tipo UTC.
Ah, ok, no, perché quelle non sono, quella lì è una stringa normale. Forse quelle lì, quando specifichi l'encoding del file, quella roba lì, forse quello, però non si fa più, è un po' primi 2000 quella roba lì.
Che avevo evitato negli script, a voler modificare tipo sopra lì, mi dai
Sì, può essere che
sì,
perché esatto, perché in quel caso lì quelle sono specifiche su tipo l'encoding del file, roba proprio di basso livello, cioè di basso livello nel senso di molto base.
Normalissimo,
Esatto.
quello che era fare due virgolette,
È un pezzo di un pezzone di stringa.
la
Esatto.
posizione di commento.
Esatto. Okay, so let's do another little piece of this lecture. So
Portarlo normale, non scrivi.
so what you had to do was, well, some of you actually it was not specified in the exercise, but what you needed to do was to edit the random.py module of your course environment, because you have two. You have one that is in the base environment and one that is in the course environment. So you had to make sure that you were in the course environment folder, lib, Python 3.9, random.py. We can open it. Oh, this will open my code editor, doesn't matter, could have been text editor, whatever. So we can just say print something here. We save the file, we close the editor, we say conda activate course env, then we say Python, and then we say import random, and this prints. So some people were not first running a Python session, but were directly writing something like Python import something random. So this is not valid syntax, because now we are in the terminal. We cannot use Python code in the terminal, and import something is Python code. So this is just terminal syntax. So what this will try to do, it will try to run a script called import, which obviously does not exist, and so this will just fail, complaining about the fact that it cannot find the import script. Okay. Always try to, it's not always trivial, but errors are super informative. You can understand a lot of what is happening if you try to spend some time reading the error that you're getting and try to think about what it means. If instead and some people instead were also writing Python, and instead of opening a Python and importing the random module, they were directly running the Python module as a script, which we can do if we write Python and then path to the random module. And this actually prints a whole bunch of stuff, which in this case is timing tests, like is running some code and performing some tests and giving us some timing results. And for the most curious among you who wants to know why this is the case, this is happening because in a script we can put a little condition, which is what is happening here at the end of the script, if name equal to main. So this condition means run this code that is here only if you specifically run this script from Python and not if you import stuff from this script. And you can see the reason, like the guy who is developing this wants to run this as a script because there's a whole bunch of testing that he wants to do to check whether the program is running normally, but also they don't want to print all this bunch, like run all those tests and print stuff if the user is importing the library. Okay, so you can hide some code from being executed when you import a library by writing this condition. Sorry?
Can you zoom in on the...
Oh, sure. Let's see. All those programs have different ways of zooming in. Sorry. Let me open it with the text edit, which I can zoom in more easily. Okay. So here at the end, like literally last lines of the script. Okay. This sometimes you can also do, like if you are writing a library yourself where you want to put some code that like definitions of functions or like things that have to run when you import, and then some testing that you want to easily run. You can, like, this is something that you can find also sometimes in, I don't know, demo code that you find, or it just means run those lines only if you run this as a script. Okay. Yeah, so from here, what we actually will be doing often is not just relying on the packages that we have in the standard library, okay? But many times we actually do things with code that was developed by third-party developers. And I mean, what we have been seeing, like NumPy, Pandas, and Matplotlib are basically used in every single piece of scientific software, like Python analysis that you will write, and all of those are examples of such third-party libraries. So it is very likely that you will end up sooner or later, if you write Python code on your own, that you will be in the situation of installing new packages. And so here I want to show you how you can do such thing, like where you can find those packages and how you can install them. So to install new packages, you will be using what is called a package manager. And the two most common ones are Conda and pip. And like Conda is the same that is also allowing us to, like, it is the same kind of tool that we were using as a environment manager, okay? But in this case, we are using it as a package manager. So it can do both. It has both functionalities. It is a very powerful tool because we can both create environments and install packages inside environments. And the basic instructions for installing new stuff with Conda or pip is very simple. Well, usually you have a problem, you start to Google, I don't know, you have to open electrophysiology file that are called .ephys. And you Google, how do I import .ephys files in Python? 90% of the times, there is a library that someone already developed for doing whatever you might need to do for analyzing your data. So you see a reply of someone say, oh, I've tried this library that you can install. So you go on the page of that library and you and usually they all start with, to install this library, you can write conda install or pip install. And yeah, so this is the syntax. You are at this point, you have a library that you know you want to use. You can just install it by writing conda install name of the package, or if you're using the pip package manager, pip install name of the packages. And the moment you're writing this command, like pip or conda are again programs, executable files that are doing a whole bunch of operations as when you write Python. And what those programs are doing in particular is that they are browsing online. So to install stuff, you will need an internet connection, because they go online, they go to a place and the two of them have different places where they look for stuff, and this is the main difference between pip and conda. They go look for code in different places, but apart from that, they are very simple. So they go to a server, and let's look at pip, for example. Pip goes to a website, which is page not found because I probably put the wrong link, but they goes to this database here, which is a huge, gigantic library, like collection of many thousands of packages that people have been creating and uploading there. And that's how they can be delivered to your Python installation, okay? and Conda goes to a different website, but like doesn't really matter. The important thing is they go online and they download some stuff. You will see like a downloading arrow because they are literally downloading code on your computer. And actually, before starting the download, they first try to find for something that is compatible with the Python that you have, with other packages that you have, with your computer operative system. Sometimes those, especially very large libraries or like very heavy duty ones, like I don't know, imaging analysis, stuff like that, can contain some compiled code that has been compiled for many different operative systems. So the package manager also makes sure that you download something that is compatible with your computer. Sometimes those packages can require additional packages that you haven't installed yet. And this is why sometimes you see that many things are downloaded and installed at the same time, because the package, especially at the beginning in a fresh installation, the main package that you're installing might require might have some additional, it's called dependency. Like a dependency of a package is another package that package relies on. And finally, after they downloaded everything, they installed the package only for the active environment where you are doing this from. So if you're doing it for the base, it will do this for base. If you're doing this for the course environment, it will do it for the course environment. This is actually one key thing. Like, it's very, very easy that you think you're installing a package in one environment and you're actually installing it in another. So always consider which environment you have active the moment you are installing a package. Okay. And in particular, they will install this package inside a folder that is called side packages that you will find in the same folder where you were finding all your standard library. You will see another folder which is called side packages with many subfolders, and those subfolders are the packages that the third-party packages that you installed. And in the installation instructions that I gave you, if you go back to them now that you know about it, you probably recollect that at some point you've wrote conda install and a whole bunch of stuff like numpy, matplotlib, whatever. That line that I gave you to run was the line that was installing all those third-party packages already. So you will see already many packages inside your side packages folder, because I already made you installing some. And each of them potentially has some dependencies, so you actually have many more packages than the one that I told you to install, because each of them had additional dependencies. Okay. One tedious and common doubt is when to use pip or when to use conda. They apparently look exactly the same. My recommendation is, if you can, try to do conda install. Many times, since conda and pip go and look for packages in different places, and for Python developers is a bit easier, I would say, in my experience, to wrap up a package to be available through pip compared to through conda. This is the reason why many times you write conda install and the name of the package that you know exists, and it will complain about the fact that that package it cannot be found by conda. That's perfectly normal. Many times people develop packages and they do not make them available through conda. In that case, you just want to go through pip and write pip install and name of the package. Also important, the first time you use Anaconda to create an environment, you will not have pip. Pip is another Python package that can be installed, and you can install it with conda the first time you want to use it. So first time you want to use pip in a new environment, just write conda install pip in the new environment, and you from that point onward you can use pip to install stuff. Yeah, last practical for today is to actually just try to open your terminal, activate the course environment, install this library that is called Faker, that probably some of you actually already saw for one of the assignments. And you can install this one using conda. So you can just write conda install and the name of this package. And then you should try to go and find this package in your site packages folder.
Io sono sempre quella che mi serve, sul resident che serve,
Ok.
però sono di qua, cioè non ho idea.
E del
Sono
resto
tante di quelle cose
dovreste
che
decidere.
Yes.
Per esempio, vedevo che ad esempio prima tu avevi fatto lo screen, come dire, del tuo post di dove avevi Python. Io invece è questo qui.
No, quello vedi che quello non è un ex.
Ah, ok.
È mezzo. Ok, quello si mette deve essere
No,
al
c'è
centro.
una cartella.
La pin.
No, non sono andato in libro.
Lib Python.
Ah, no, I've been.
Ah, ok. Cioè è giusto che non ci sia una cartella.
Cioè quella lì, no, quella lì non è la cartella dell'ex sfruttatore, quella è la cartella dove ci sono le librerie. Che nel mio caso è sotto lì. Non sai, ma forse tu hai sbagliato tutti hanno una cosa dentro.
Sì. Ah, ok.
Quindi nel mio caso anche Andrea aveva una cartella.
E qua non ho proprio di nuovo, non ho Python totale.
No, ma non quello che voglio dire, era solo una sottocartella in cui
Ah, ok.
stata roba della. Cioè non ci trovi dentro
Ah, ok.
le So maybe we can start next lecture from here, like correctly.
I hope this is not too annoying, like this is not exciting using data, etc. But like it's very important to get to know your Python installation before using it. Sure. Thank you.
Ciao.
Poi la soddisfazione è già reazione, invece sentire